Okay. So for number 1, we're going to take 20. We're going to take 21, and we're going to add to that 37, multiply that by 1 over 60, because that's the conversion vector into minutes. And then we're going to take 51 and multiply that by 1 over 3600. So when you get that, you get 21.61, and then plus this part over here gives you 0.014. So you get an answer of 21.62 degrees. When you go the other way, though, when you do 87.2422, you want to take it to degrees, minutes, and seconds. Well, there's a full 87 degrees. We're going to add to that 0.2422. We're going to multiply that by 60 to get back. Take that answer, and that gives us I think that's going to give us our full 14 minutes. And then we're going to add to that 0.532 times the 60. Now I know you guys, where does that come from? So let me show you. So when you take 0.2422 and multiply it by 60, this gives us a full 14 minutes. And then the 0.532 is where I got this one. Multiply that part by 60. And that gives us the remaining part of 31.92 seconds. So our answer would be 87 degrees, 14 minutes, 31.92 seconds. Sweet. There you go. Okay. Number 2. Find arc length. So we're looking for this distance right here. That's what we want. We're going to call this distance S. So we know that S is equal to R times theta. So S is equal to my radius, which I know to be 5 inches. So it's going to be 5 times 86 degrees. But the degree must be in radians, so we take that answer and we convert our degree to a radian by multiplying by pi over 180. So S is equal to 5 times 86 times pi over 180. So our S is equal to 7.5049 inches, or some people might have that as, I think it was 43 pi over 18, or some people might have it as 215 pi over 90. All of those are the same. So we can just round to 2 decimal places. This one will be totally fine when you work with it. Alright, cool. That's number 2. Here we go. Number 3. Find the exact value of all 6 trig functions. Let's see here. I know that this side here is 12. I know this is 15. I know this is 9. I have a 90-degree angle in here. So this should technically be like that. So sine of angle C. So here's angle C. So the sine is opposite of ours. So this is going to be 9 over 15. That means this has to be 15 over 9. Cosine is 12 over 15. That means it's 15 over 12. And the tangent of C should be 9 over 12, which means this is 12 over 9. That one couldn't be any easier. All you got to know is basically the trig function sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There you go. So as long as you know that, you can figure out all those trig ratios for that one, for number 3. Okay, number 4. Find the cosine if 4 negative 5 is a point in the terminal side of theta. Draw an accurate picture. Okay, so check this out. Where is this point? Okay, so we have to think about that. 4 negative 5. That's over here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Boom. That is somewhere over here in quadrant number 4. So my angle theta in standard position is that. So my reference angle is right here. So this gives me 4. This is a negative 5. So we got to figure out what our radius is. So radius is the square root of negative 5 squared plus 4 squared. So our radius has to be the square root of 25 plus 16. So our radius has to be the square root of 41. So figure out the cosine. So the cosine of theta, here's my theta, is the adjacent to the hypotenuse. That's going to be 4 over square root of 41. So theta is equal to, cosine of theta is equal to 4 square root of 41 all over 41. And that is your final answer for that one. Okay, so number 5. Reference angle for 42 pi over 8 over radians. Draw an accurate picture to support your answer. Okay, so let's see here. How about this? How about 40? Yikes. Think about this. 42 pi over 8. That's the same thing as 40 pi over 8 plus 2 pi over 8. Okay, why would anybody do that? Take a look at this. 40 pi over 8. That is the same thing as 5 pi. This is the same thing as pi over 4. So 5 pi is going to look like this. That's 2 pi because I went all the way around. So that's 2 pi once, right? I'm going to go around again. That brings me to 4 pi. I go one more to, this is 5 pi over here. And then I have a little bit more to go. I have a 45-degree angle in quadrant number 3, right? So that means the reference angle is the angle that's in between my terminal side and the x-axis. So my reference angle right there is a pi over 4 reference angle. And I got that by breaking down this fraction. So that's the key to doing it. Figuring out how many times around you can go and figure out where you end up and what quadrant you end up in. Okay, cool. Number 6. Here we go. Sine theta is a fourth, and secant is negative. Find the exact value for cosine and tangent. Draw an accurate picture. Okay. So you got to ask yourself, if the sine is positive and secant is negative, what quadrant do you have to be in? So make that little chart for yourself, and you should realize that you have to be in quadrant number 2 in order for this to work. Okay, so here's your angle theta, here's your reference angle, and we know something about this. We know that the sine is 1/4, so that means that this has to be 1, this has to be 4, and this we find by using the Pythagorean theorem, which happens to be negative square root of 15. Now the reason it's negative is because I'm considering a point over here, and that point would be negative square root of 15 comma 4, right? So I need to find the cosine and the tangent. So the cosine of this angle has to be the adjacent to the hypotenuse, so that has to be negative rad 15 over 4, and it makes sense that it's negative because the secant is the negative, and cosine and secant are reciprocals of each other. And that means the tangent of theta has to be the opposite to the hypotenuse, so negative 1 over rad 15. But again, we multiply by rad 15 over rad 15 to rationalize. So tangent theta has to be negative rad 15 over 15. So there's my tangent, and there is my cosine. Sweet. Okay, find the exact value for cosine 3 pi over 4 minus 5 sine pi over 3. Okay, so we're going to say 4 times cosine of 3 pi over 4 happens to be negative rad 2 over 2, right? And that is straight off the unit circle. It's one of those angles that we need to look at. That's to be minus 5 times the sine of pi over 3 is a 60-degree angle, so that's going to be rad 3 over 2. Rad 3 over 2, and I got these straight off the unit circle. Alright, so the unit circle bite size, you have to look on there and see what you get. So this is going to give me negative 4 rad 2 over 2 minus 5 rad 3 over 2, which means I'm going to have negative 4 rad 2 minus 5 rad 3 all divided by 2, and I leave my answer just like that. I cannot combine this rad 2 here and this rad 3 there. They are not the same. So my whole answer is just that part in the highlighted piece there. Okay, number 8. If the cosecant theta is 4, find the exact value for cosecant theta plus secant 90 minus theta. Okay, here's what you have to recognize. Cosecant theta we know is 4. Secant of 90 minus theta is, notice that secant and cosecant are cofunctions, right? And whatever, if this is theta and this is 90 minus theta, then that means that they're complementary. So if I had like the, if I had the cosecant of, let's say, 10, and I'd look before the secant of, say, 90 minus 10, well, that'd be cosecant of 10, for example, and that would be secant of 80, right? So those are complementary, and these are cofunctions. So that means that they have to be equal. So that means that this piece also has to be a value of 4, and I know it's 4 because I get from that part over there. So this is just asking me what's 4 plus 4, so the answer is really just 8. Huh, interesting. Alright, number 9. given f of x equals 4 plus 5 sine blah blah blah, I'm answering. Okay, vertical translation. So this problem is all about knowing what the pieces do. The vertical translation is right here, so that means we're going to go up 4 units. Alright? The amplitude is the part that's sort of outside or right in front of being multiplied by your trig function. So we're going to say the amplitude, this is the distance from center to the top and the bottom is 5 units. So it looks something like this. Right. This distance here is 5 units, and that distance there is 5 units. The period is found by, for our sine curve, taking 2 pi divided by 6, which gives us pi over 3 radians. So that means that that's the distance to complete one cycle. Alright? That's what that means. And then the phase shift is this part, so that's going to be pi over 7 units to the right. Okay, and then finally for the last one here, I'm going to figure out the 3 things that I'm going to do. Okay, this -4 is going to be an amplitude with a reflection because it's negative. Okay, then I need to actually rewrite this so that I can read it as -4 sine of 2 times x minus pi over 2. And the reason we're doing that is because I need to figure out what my period is. So my period is going to be 2 pi divided by 2, whatever number is right there. So that's going to be a period of pi. So there's my period. That's my distance to complete one full cycle in radians. And this part, this little right here, tells me I'm going to have a phase shift. Pi over 2 units to the right because it's the opposite sign. So I'm going to choose to do phase shift first, period second, and then amplitude third. So that's what I'm going to work on right there for that part. Okay? So I'm going to draw my graph, get it all squared away here. Alright, and my amplitude is going to be a -4, so I'm going to have to go up 1, 2, 3, 4. And I'm going to go to 5 just to make it a little bit, give myself some room. 1, 2, 3, 4, 5, -5, okay? If that is 0, and this is 2 pi, then halfway between is pi, halfway between that is pi over 2, and this has to be 3 pi over 2, and then I know I'm going to have to go out one more, so that's going to be 1 pi over 2, 2 pi over 2, 3 pi over 4, 5, so 5 pi over 2. That's how I did that. Okay. I'm going to start with, the first one is going to be my sine curve, so sine of x. So I'm going to have 0, I'm going to have 1, I'm going to have 0, I'm going to have -1, and I'm going to have 0 again. So I start with my sine curve, and it looks like this. Next piece of information I want is I'm going to do a phase shift of pi over 2 to the right. So I'm going to do sine of x minus pi over 2. So that means each dot gets moved to the right 1 unit. So that dot goes there, this dot goes there, this dot goes here, that dot goes there, that dot goes there. So here's my phase shift, okay? Then the next thing I'm going to do is I'm going to have to do a period of pi. So if I start here, I have to end on a distance of pi. That right there is one distance of pi. So I'm going to start and end here. Halfway between I'll be here. Halfway between I'll be there and there. So I know I'll be up here, down here, below here. So here's my new graph. Now it'd be great if we could figure out what those actually are. So I cut this in half. That's pi over 4. So that's 1 pi over 4, 2 pi over 4. So this is 3 pi over 4. 4 pi over 4, and then finally 5 pi over 4 here. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, and then finally 10 pi over 4. So I can keep on creating this one and just duplicating my cycle all the way around. So I'd have something that looks like this. Because I want to graph this thing on from 0 to 2 pi. So I've done phase shift, period. Last thing to do is the amplitude and the reflection, and I'll do that in... Oh shoot, I'm running out of colors. How about green? Okay, so we're going to take this point, and we're going to keep it there. We're going to reflect this one and make it down to 4. So that point's going to go here. This stays here. This point goes up to 4. This point stays there. This point reflects down to 4. This point stays there, and this point reflects up to 4. So when I'm all said and done, I have this beautiful looking graph here, and then I'd come back down and meet it right there. So if I was going to keep going with this, then this point would be up here, and then this point would be coming back down and be right there. Okay, so I highlight the very last one that I do. So the very last one should look something like this, and we would then check this on the calculator to make sure that we did this right. So again, make sure when you plug it into your calculator that you're always in radian mode. So I'm going to go to y equals, go to my window. I'm going to go 0 for my x scale. My biggest one is 5 pi over 2, so 5 pi divide 2, enter. The scale that I'm going at is pi over 4, so I'm going to go second pi divide 4, boom. My lowest is -5, and my highest was 5. So I'm going to punch in my calculator and make sure I got that. Go to y equals, I'm going to punch in this equation right here. I'm going to go -4 sine 2x minus pi. 2x minus second pi. Close it. Hit graph. Boom. That looks pretty darn good to exactly what I have. So if I count, if I go over 1 pi over 4, I should be up at 4. So I look here, 1 pi over 4, I'm up there at 4 for sure. So it looks like I did it right. Alrighty guys, good luck. You guys will do great.